Hello, Mr. Strader here, and as promised today in class, I'm going to go through the answers to the quizzes that we've taken so far, and make a little YouTube video, and hopefully that will be useful in studying for your upcoming assessment, or to just review as the year goes on. So here we go, let's do it. First question, what is the value of x when f of x equals 6? So we're looking for what value or values, if there are any, can we input into the function f of x so that the output is negative 6. So that negative 6, that output, that's a y value. So let's look at the graph. For all the points on the graph that have a y value of negative 6, I think there's only one. I think it's that point right there. So I'm looking for what x value, when I evaluate the function at that x value, gives me a y value of negative 6, and that would be 3. Because the point on the function is 3, negative 6. That makes the answer choice B. Moving on, number 2, what is the equation of the line shown? Well, if you look at this line, and you write down some points on the line, I'll make a little table here of some points that are on the line. We've got 0, negative 5. We've got 3, negative 5. We've got 7, negative 5. We've got negative 1, negative 5. That's right there. We've got negative 10, negative 5. So every point on this line has a y-coordinate of negative 5. So I think the equation of the line is just y equals negative 5. For every point on the line, the y value and the coordinate is negative 5. It doesn't matter what the x value is. The y value will be negative 5 if the point is on the line. Great, moving on. 3. What is the standard form of the equation y equals the quantity x plus 5 times the quantity x minus 3? So it looks like we have a quadratic function here, a quadratic equation, and to get the standard form, let's just multiply out the right-hand side. So to do that, I'll erase here, give myself some space. I'm just going to use sort of this area model to collect my work. I'm multiplying x minus 5 by x minus 3. So I'm going to use the derivative property to multiply x by x and x by negative 3. Give me x squared and negative 3x. And I need to distribute the 5 as well, so I get 5 times x. And 5 times negative 3, which is negative 15. And I just need to collect like terms. It looks like I get x squared, and then 5x minus 3x gives me 2x minus 15, so I'm just adding all of these terms in here. So that is answer choice A. Alright. 4. Which of the equations below is written in factored form? Well, A is written in standard form. That's standard form. B looks like it is written in vertex form. D is, written in standard form, but not really, because I haven't collected all the like terms, so it's not quite in standard form. And C is in factored form. I've expressed this polynomial function as prime factors that we've multiplied together. This x plus 3 times this x minus 7. C is in factored form. Alright, 5. What is the most simplified form of the function y equals the quantity x minus 2 squared minus 3? So I don't really like this question, because you could consider, this quadratic function is written in vertex form. You could consider that quote-unquote pretty simple. I think what the question, whoever wrote this particular question, I think what they were going for is what sort of, if we wrote this function in standard form, what would it look like? I think that's what the person was going for. So I'm going to sort of multiply out the quantity x minus 2 squared, so that's x minus 2 times x minus 2, and then I've got to subtract 3. So I don't have a ton of space here, so I'm not going to use that area model or that quote-unquote box method that I hear some people referring to it that way in class. to use the distributive property here, I've got x times x is x squared, x times negative 2 is negative 2x, then I've got negative 2 times x is negative 2x, and negative 2 times negative 2 is a positive 4, and then I've got to subtract that 3. So if I collect like terms, I get x squared minus 4x plus 1. Looks like it's answer choice D. Alright, which of the following expressions is the logarithmic expression equal to, again, sort of some typos here in these questions. So we're looking for an equation that is equivalent to 2 to the 4th equals 16. I think that's what the author of the question was intending. So I want an equation that carries sort of the equivalent information that the statement 2 to the 4th is 16 carries. So 2 to the 4th is 16. That's sort of an equation that I would say is an exponential form, so to speak. And I want to write this in sort of logarithmic form. So the definition here is if I have a base raised to a power equaling an answer, I'll say, that is equivalent to writing log base b of my answer, and that equals the power. So if I have the equation 2 to the 4th equals 16, my base is 2, the exponent power is 4, and 2 raised to the 4th power is 16. So if I wrote that using a logarithm, that would be log base 2 of 16 is 4. Those two equations are equivalent. So that leads me to answer choice D. Alright, on to the next page here. We're looking for the end behavior asymptote of the function y equals 5 to the x plus 3 minus 1. Let me just draw a quick sketch. A calculator would probably help you out here. Function does have an EBA of y equals negative 1, and just a really quick sketch, it's going to look something like this, without putting any other scalings on there, just drawing a really detailed scale. It's just like a very rough just idea of what it would look like. You can check that on your graphing calculator, and the end behavior asymptote is y equals negative 1, answer choice D. Great, now we have a series of composition problems using f of x, g of x, and h of x given here. So number 8, saying what is the value of g of f of 3? Let's work from the inside out here. Let's evaluate f of 3. So that means that using the function f of x, everywhere I see an x, I'm going to replace that x with a 3. So f of 3 is 2 times 3 plus 5, which is 11. But this is asking us to evaluate g of f of 3, and f of 3 is 11, so now I need to evaluate g of 11. And that is going to be 11 minus 2 is 9, so g of f of 3 is 9. So the key for function composition, sort of working the inside out, usually does the trick when we're working with composing functions. So number 9, what is f of g of x? Well, that means, first I'm going to write down what f of x is. It's 2x plus 5. But the question isn't asking me what is f of x, it's asking me what is f of g of x. So it's really asking me for f of g of x. So that means everywhere that I see an x, I'm going to replace that x with g of x. But what is g of x? G of x is x minus 2. So really, f of g of x is 2 times g of x, which is x minus 2, plus 5. And then if I just distribute the 2 and collect like terms, I get to 2x plus 1, which is answer choice A. So now, number 10, we're not composing functions, we're just adding functions. This says, what is the value of f of x plus h of x? Again, a lot of little typos here. Value implies that f of x plus h of x would be like a number. I just think that the question should say, what is f of x plus h of x? Now, what is the value of? I'm just adding the functions f of x and h of x together and seeing what I get. Well, f of x is 2x plus 5 plus h of x is x squared plus 3x plus 4. Now, I'm not multiplying f of x and h of x together, I'm just adding them together, so I'm just going to collect like terms here. Looks like f of x plus h of x is x squared. Looks like I have 5 x's and a constant value of 9 there. So that gives me answer choice B. All right. Now we're looking for the inverse function for f of x. Well, if f of x is y equals 2x plus 5, I'm using y instead of f of x just because when dealing with inverse functions, I usually use x and y instead of x and f of x. Just personal preference. So the inverse is going to be, for every point on the graph of f of x, we're just going to interchange the x and the y parts of the coordinates. So algebraically, I'm just going to interchange x and y. So there's the inverse function, but now I want to resolve this for y to get an equation for the inverse function for y in terms of x. So I'll subtract 5 and divide both sides by 2. So that is x minus 5 over 2 is the inverse function. So f superscript -1, that superscript -1 means it's the inverse function of f. And that is answer choice C. 12, what is the value, again, I shouldn't say what is the value of, correct wording there, it should just say what is f of x minus g of x. Great, so f of x is 2x plus 5 minus g of x, which is x minus 2. Now I just need to distribute this -1 and collect like terms. So I get 2x plus 5 minus x plus 2. So that's going to give me x plus 7. Answer choice B. Next. Given the graph of f of x, how many solutions are there to the equation f of x equals 0? So we saw a question like this in the multiple choice. So we're looking for what can I input into the function, into x, so that the y value is 0. Well, there's only one point on the graph that has a y value of 0. And that is -3, so it looks like x is -3, because f of -3 is the x value, the output is 0. So the only solution is x equals -3. It's the only x value such that if you evaluate the function at that x value, the y value is 0. What are the zeros of the function whose factored form is y equals 3 times the quantity x minus 1 times the quantity x plus 4. So we're trying to solve the equation y equals 0. I'm sorry. Yes. I'm finding the zeros of the function, looking for all of the x values such that when you evaluate the function at that x value, the y value is 0. So I'm trying to solve the equation 0 equals 3 times the quantity x minus 1 times the quantity x plus 4. So I can use the zero product property. The equation's already factored. So I know that this is a true statement if x minus 1 is 0. So if x is 1. Or if x plus 4 is 0. So x is -4. So those are solutions. And that factor of 3 there, 3 can never be 0. That would make sense. So that doesn't give me any other solutions there. So it's just those two solutions, or those are the two zeros of the function. The two zeros of the function are located at x equals 1 and x equals -4. Using the diagram, find the following. I'm going to go ahead and assume that this has some arrows on it, that we're dealing with a nice continuous quadratic function. Domain for quadratics, for any polynomial, all real numbers. The range, the lowest absolute minimum y value is -8. But for any value larger than -8, there's an input that will produce that output. So the range is -8 to infinity. Y can be anything -8 or greater. Oh, x-intercepts appear to be -1, 0, and 5, 0. And the y-intercept looks like it's 0, -4. Excellent. Moving right along, we got a little square root function here. F of x, filling in the table, square root of 0 is 0, square root of 1 is 1. Great, great, great. I could have also looked at the graph, could have gotten those coordinates right from the graph. Translate this function 5 units up, graph and label your new function g of x. So basically what this is saying is that it's saying that g of x is f of x, but shifted up 5 units. So we should be familiar with that now that we've talked about some transformations in class a little bit. So if I translate this up 5 units, every point would get shifted up 5 units. And there's g of x. Great. The domain of g of x, if I input any x value less than 0, the output would be imaginary. So in terms of real numbers, the domain will be 0 to infinity. And the range looks like it is 5 to infinity. 5 is the smallest y value that g of x outputs, but g of x can output any y value larger than 5. We can find an x value that will do that. When is the graph increasing, decreasing? Well, g of x is never decreasing, and it's increasing over its domain, which is 0 to infinity. Home stretch here. We got this function f of x. We want to find the value of f of -3. Well, that would be 2 times -3 squared minus 4. Make sure when you're substituting -3 in for x, make sure you use parentheses. And now I just have to follow order of operations. -3 squared is 9. 2 times 9 is 18. Minus 4 is 14. So f of -3 is 14. I'm going to solve this log equation for x, so I'm going to come back to my definition. If I raise a base to a power and that gives me an answer, that is equivalent to saying log base b of a equals p. So I have, well, first of all, my double arrows sometimes do not look really nice. That's just really bothering me for some reason. Double arrow. So if I have log base 4 of x minus 1 equals 2, just blowing some hair off my iPad screen there. The base is 4, the power is 2, and that will equal x minus 1. And now I can just solve that equation. That is 6 says 16 equals x minus 1. Add 1 to both sides, so x must be 17. That is the only solution. 20, we've got to factor this expression. Let's look for a greatest common factor here. The greatest common factor of 5 and 25 is 5, and the greatest common factor of x squared and x is x. So I believe this factors to 5x times the quantity x plus 5. Now remember, whenever you factor, you can always check yourself by using the distributive property. If I distribute the 5x through this binomial, I should get back 5x squared plus 25x. So 5x times x is 5x squared, and then 5x times 5 is 25x. So that checks out, it works. So you can always check yourself if you're not sure when you're factoring. I'm just going to erase to leave that factored form there. Now I've got to factor 4x squared minus 9. This one I bet gave some people some trouble. It's a little trickier. There's no greatest common factor over the integers between 4 and 9 other than 1. And that 4x squared, 9 doesn't have, it's not being multiplied by any x's, so it's just the constant -9. So I guess we go into some guess and check mode here. Maybe try 2x and 2x, and now I need to think of these last two numbers are going to have to multiply up to -9, so maybe -3 and +3. And then again, I'm not just going to leave that as my answer. I'm going to check to see if that works. I'm going to check to see if I have the right answer. I'm just going to multiply out 2x minus 3 and 2x plus 3 and make sure I get back 4x squared minus 9. And I do. So I multiply this out, use the distributive property, and then collect like terms. That gives me 4x squared, but then minus 6x plus 6x is 0. So I wind up with 4x squared minus 9, which is exactly what I wanted. So factoring 4x squared minus 9, that factors to 2x minus 3 times 2x plus 3. And that wraps it up. So hopefully this helps, and use this to review. Good luck.